Hi there. Let's look at this slide again. We reviewed how bioindicator species can help us monitor water quality, and we looked at the stats on this river once already. Just in general, though, let me point out a few more things about our river. Remember, good quality water with lots of oxygen will have things like snails. They'll have caddisfly, mayfly nymph, stonefly. Medium quality water is going to have dragonfly nymphs, damselfly nymphs, clams and mussels, crayfish. And then poor quality, which is 4 parts per million oxygen or smaller, is going to have midge larvae, black fly larvae, leeches especially, aquatic worms, maybe bacteria. And so if we notice the river, it flows this way, and we have a sewage outlet. So this is dumping sewage, and we have a farm which is going to dump probably due to leaching manure. So site B is going to be really unhealthy, site B. And so if we go to up here to site B, we notice lots of aquatic worms and midgefly larvae, which according to this, aquatic worms, midgefly larvae, that indicates poor quality water. Site C is also fairly bad, but you'll notice that the numbers are going down. And then site D, those numbers are going down even more. And pretty soon now we're getting medium quality water in site D because we've got dragonfly nymphs. And why is that? What's happening? Well, as the water moves down the river, it gets reoxygenated due to the turbulence of the water, and the chemicals start to diffuse away. Okay, so they don't last forever. Next thing you know, site E and F. If we look at site E and F, we'll notice it's getting back to medium to almost good quality water. Remember stonefly nymphs, which there's lots of in site E and F, and dragonfly nymphs are a site of medium quality, and so those two are helping to make the water good again. How about site A? Site A should be okay water because it's above or upstream from these two places where you'd get bad water. Water treatment is our last topic, and so we want to think about several ways to keep yourself safe from dirty water, and that's keep contaminants out, make sure you test to avoid contaminated water, kill microorganisms, and remove the contaminants. So how do you keep contaminants out? There are several things that you can do to keep contaminants out of drinking water. You can use special filtering systems. Whoops. And so we'll get into water treatment plants in a moment later on. Test and avoid. As you know, there are all sorts of test kits we can use to help test it. And you can kill. Iodine is one method that we might use to kill microorganisms. Chlorine is a disinfectant that we add to actually most city water treatment plants will use chlorine. Bromine is another one that is used as a disinfectant. And we can remove contaminants through filters. Reverse osmosis is a way. It doesn't necessarily effectively remove bacteria and harmful microorganisms, but it does remove impurities. And so normal osmosis, fresh water, goes in this direction. However, we can use a semi-permeable membrane and pressure to force the water reverse backwards. Flocculation is used especially in water treatment plants where you take dirty water, you add floc like alum, and that causes all the sediment to clump together, and then you scrape off the floc. Here's how most water treatment plants work. Screening is step one, so these are large screens that remove twigs and large debris. Then you add floc, which helps clump together into a jelly-like substance, and then it clarifies. That means the floc is scraped off, and then you filter using a special smaller porous filter. Then you disinfect once, usually using ozone or sometimes sunlight. And then you add a second disinfectant, usually chlorine, that will kill any other bugs. And then you store it in what's called a service reservoir. A service reservoir is a tank that's protected. It's not an open area like you're seeing in the picture. An open area would be fairly harmful. So it's inside the water treatment plant. So this isn't the service reservoir we're talking about. This would be like Glenmore Reservoir. And then it's pumped from there to a mixing chamber, a settling tank, sand filters, and so on. I want to talk about invisible water. Underground water is sometimes forgotten because we can't see it, but there is the water table, which is the line that sort of tells you where the top of the underwater is. This underwater system is called an aquifer, and we often can tap into the aquifer with wells. So here it is again. Here's our aquifer, large accumulations of underground water, and there's the water table right there. Let's talk about biodegradable stuff. So biodegradable waste is a type of waste that comes from plant or animals, and it usually can be broken down. So paper comes from trees, banana peels, and so on. Some substances take a long time to break down, though. So we will end with the two types of landfills. This is a sanitary landfill, which means there's usually earth that covers up the remains, and the garbage is crushed each day, and a waterproof liner is put over top of it. If we have paint or other chemicals, we don't want it to go into a sanitary landfill because there is the possibility still of leaching that could go on and get into our aquifer. So we would put it into what's called a toxic waste or a secure landfill. So that's for toxic waste. And the toxic waste has pipes to allow for venting, and it also has lots of clay and liners to protect and prevent leaching. Besides water and soil, we should also be aware of air pollution and be able to monitor air quality. Global warming is a type of air pollution where carbon dioxide is building up in our atmosphere, and that's causing the earth to heat up. Here's a quick check on your vocab, making sure you have all your vocabulary. You can pause if you want to check that out. Let's do this practice quiz. So calculate the concentration from topic 4 of solution in parts per million if you have 0.0006 over 100. Remember, if we have the same units, so let's make a ratio 0.0006 out of 100. If the units are the same on the top and bottom, we can say, okay, how much is that over a million? 1, 2, 3, 1, 2, 3. So what do we have to do? We have to times by 10,000, and so we have to times the top by 10,000. That's moving the decimal place 4 places to the right. So here's the decimal, 1, 2, 3, 4. So the answer would be 6 parts per million. Which of these organisms can cause serious health problems if they're present in large amounts? Bacteria, of course. What's the minimum level of oxygen to support most organisms that live in lakes? Probably the minimum level of dissolved oxygen to support lots of, probably right about there. We know good oxygen is somewhere around 4 or less. Sometimes is poor oxygenated. A few weeks, a farmer spreads fertilizer When he talks to an agriculturist, he learns that most likely reason for his algal blooms is the fertilizer has dissolved into the water and passed through the soil into the pond. As a result, algae have benefited from the fertilizer. What is the term used when the liquid passes through the soil like this to cause the algae blooms? That's called leachate. Most people enjoy many foods that have peanuts, yet people have a severe allergic reaction, may even die from eating a single peanut. What do we call this? This is called acute. Acute means it happens immediately. Chronic means it might happen over a long period of time. A large population of worms and a few insects is an indication that a particular bottle of water is not healthy. Okay. So here are some chemicals, A, B, C, D, E, and their parts per million LD50s. Remember, the lower the LD50 in parts per million, the bigger its toxicity. If 5 people were to consume one of these items listed at the same quantity as others, who would experience the highest lethal dosage? So if 5 people were to consume one of the items listed at the same quantities, who would get the highest lethal dosage? Well, the most toxic substance on this list is the botulinum. So if everybody, let's say everybody had 0.4 parts per million, this person had 0.4 of their chemical, this person had 0.4 of their chemical, and so on. If everybody had 0.4 parts per million, who would get the most lethal dosage is what it's saying. Well, the most toxic substance here is botulinum, because look at how low it can get to kill 50% of the population, and therefore person E would get the most lethal dosage. Algal blooms represented in this picture, what about it? Are these good? Is this a good, healthy thing? No, it's unhealthy. And what causes it? So the answer is D. Algal blooms are unhealthy for the pond, and fertilizer and manure can cause it. Remember, once it gets blanketed, all these plants will be gone. If the plants on the edges are gone, then there's there will be no O2. No O2 means our oxygen levels get really low, and that means there'll be bacteria, and it'll be basically a detritus pond, non-oxygenated, anaerobic organisms like bacteria. 2001, a water sample was taken. Here's our river. The river goes in this direction. So here's the urban, A and B. The river flows this way. Okay, here's sample site A, 2001, and then same samples taken in 2003, site B, along the river, and so on. The most like a water sample was taken in location F. And so what did you notice between 2001 and 2003? Here's site F. There's rural farmland that could help manure leach into the water. What happened? The beetles, mayfly larvae went way up. Aquatic worms went way down. Leeches went way down. So the water got better. Why? What was the most likely reason? Oh, in 2001, a water sample taken at location F showed high levels of nitrates and phosphates. Why is that? Rural farmland means large cattle upstream probably caused this. In the fall of 2002, a new sewage treatment facility began operating along the river. From the data collected, it was likely built where? So this is going to help treat the water to make it healthy, sewage treatment plant. Where did they put it? Well, which site from one year to the next got a lot better? Which site from 2001 to 2003 got really healthy? Location A? No, location A got worse from 2000, so not location upstream. Between E and F, here's E. What's E like to F? E and F's pretty good. How about C and D? C and D.